Okay, next one. I don't need to spend too long on this. You were fabulous on this on the unit assessment. So it says, explain the factors that contribute to stopping distance. So we're going to have to explain what that is, what makes it up. And it says, explain how these are affected by the driver, the car, and the road. So I'm going to have to say a bit about everything. Now, when I did that in class, I don't think I did the road bit as well as I should. So I'm going to do it slightly different this time. Well, the first part I need to say is stopping. Let's change that. Stopping distance equals thinking distance plus braking distance. I'm going to tidy that all up because that's a lot for me to write. I can't believe I've written it already. So I'm going to go stopping distance equals thinking distance plus braking distance. And I have to state that, say what stopping distance is. And as we know, the thinking distance, this is to do with the driver's reaction times and the speed that they're going. So this first part, the thinking distance, and I'll just write that here, that is distance equals speed times time. The braking distance, BD, that's all to do with the kinetic energy of the car. And as we've learnt, that's half mv squared. And it's always a nice place to go. You want to talk about braking distance, talk about masses, talk about velocities. And I can do that in terms of the car. And then the road will come into the braking distance part. The road should have no effect on my thinking distance. Okay, so by the driver. So, well, we can now talk about, well, the driver can have an effect on the thinking distance. We can increase that if they're on drugs or due to tiredness. Now, please don't use an increase arrow in your assessment. So there's the driver bit done. So the driver, their reaction time. So I'm going to write their reaction time is a big factor in this. And if they're on drugs, if they're tired, their reaction time will increase and the thinking distance will increase because that distance equals speed times time. So if this bit goes up, that bit goes up. So we've done that part. That's the driver. Now we're going to do the car. Well, the car's going to relate, and I'll change my colour for this part. I'll pick that lovely little blue there. That's to do with the braking distance. So now I'm going to talk about the car. And I'm going to say, well, the car, the crucial parts about that is half mv squared. So things around the car, the things that could affect it. And I'm going to say, well, what could affect the braking distance? I could increase the braking distance through the following things. I could increase the mass of the car. That's that part there, that mass. I could increase the velocity of the car. Why? Because increasing any one of those things will increase the kinetic energy of the car. That will increase the braking distance. So that's that part done. And then the bit that I don't think I did particularly well in lesson is the road. So I've done the driver, the car. Now I'm going to do the road. And again, I'm not linking that to thinking distance. And I'm going to keep it easy by going, I'm going to increase the braking distance. And as we know, increase any of these things, that's a bad thing. So what I'm going to say, well, one of the things that could happen, and this has never been more true than the other day at school, is I could have a wet or icy road. That will increase the braking distance. Why? Because I reduced the friction. Now, if you're answering that at grade 9, what we'd then look at is this idea of half mv squared, the kinetic energy of the car, equals the work done by the brakes. Okay? And therefore, if there's less friction, then I need to use a greater force to get myself to stop this. And that's that. I hope that helps. Ignore all of this stuff though, guys. That is not required.